Welcome back to another episode of Automating Minecraft. This is a series where I write code to automate tasks in Minecraft, hopefully in a way that doesn't bore or push away people that don't know about programming. In the last episode we automated nether journeys, and that episode ended with me flying over here to my brick and terracotta factory, where we're going to be making the production process a lot easier for me. So if you don't know, mud with a dripstone underneath will eventually turn into clay. From clay you can make clay balls, then smelt them into bricks, or with silk touch you can get clay blocks and smelt them into terracotta. Now I can hear you, Bob, is that the best way to make bricks and terracotta? And yes, that is how I read all of your comments. And so let me say, for bricks, yes, but for terracotta, best is subjective. So the two things I want to automate today are the collection of mud and placing mud on these platforms, and then removing the clay when that's done. So if you haven't seen the last two episodes, the code I write can only press my keyboard and move my mouse. It can also see what's on my screen, but that's quite basic. So it's kind of like a player. You should get what I'm talking about as we work through this first task. So for collecting the mud, what can I do about this? What I find really annoying when harvesting mud is when there's dirt in the way, and I break that instead, and then my inventory gets clogged up with dirt, and then I have to throw that away, and then I accidentally pick up the dirt, and I have to throw it away again, and then there's more dirt, and I accidentally mine it, and then the process continues until I eventually collected enough mud, and I can finally relax. So I'm not actually sure with this one if there's much I can do about this. What I'm thinking is that if I have a program that holds down the left mouse button, then looks at the center of my screen and determines if I'm looking at mud or not, then if I don't look at mud, stop pressing the button until I start looking at mud again. This might work, but I'm not sure if the program will be fast enough, because with efficiency 4, which I have, you can mine mud and dirt instantly, so it might stop me from mining any after the first piece of dirt, but after that the damage is kind of already done. But let's have a look. Okay, so I've just written the code. I'll show it off in game first, and then I'll go through the code. So I'll first just use my fist, because I think it's going to be easier to actually see what it's doing than using a shovel, which breaks blocks quite quickly. So I've set the button to being the 2 button on my number pad. So if I press that down, you'll then see two things appear on the screen. On the left, you see the area of the screen that the computer is looking at. On the right is all the areas that the computer says are mud colored. So the left is what we see and the right is what the computer sees. So you can see if I look away from the mud, it goes black because I'm looking at the dirt here. But if I look towards the mud, it goes, oh, please let me just, I just really want to break the mud, please. Let me, yeah. So let's go and take it towards, and you can see it's very happy. Oh yes, I can break all the mud. Oh, there we go. I can break all the mud I want. Yeah. So sometimes, yeah, there we go. And obviously, when I look at when I look at dirt, it does stop. Now, sometimes with the mud, like if I look at the underside here, it'll go, what is this? This is obviously not mud. And obviously we can see that it is mud. The problem is that when things get darker, their color changes. And when things get lighter, their color changes. Right? So I can make it so that it can identify this as mud. But we kind of get into a state where it identifies anything dark as mud. So then it can kind of mistake sometimes dirt, or sometimes if you're maybe stone, if it kind of gets a little bit dark down here. So it can get confused sometimes with some other blocks, but most of the time it's pretty accurate. So as you can see, it is working, and if I'll go and get out my shovel so you can see that. Right, okay, so start breaking mud, we can see that it works, and then when I look at dirt, it stops working. Now, the only problem that I've found is if I break mud, there we go. So if I'm breaking mud and I'm going and I look at dirt, if you look at what the screenshot it's taken, you can see it's a little bit slower, right? It's a little bit slower than what I'm actually displaying on my screen, meaning that it might think that I'm actually looking at this mud, but actually I've moved to look at this dirt. And it can't see that fast enough because it is a little bit slower. So that's why it's not entirely usable, but it is pretty cool. It was pretty fun to go and put together. Now the code for it is actually quite simple. It didn't take me too long to go and write. So yeah, I'll go and show that off now. So initially this is going to look scary for people that don't know programming, or maybe people that have just started programming. And you both are probably not going to understand this fully when I'm done explaining, but hopefully it'll get it less intimidating. So what I have here, like last time, is just the name of the task, and a bit that says copy the code that we wrote in episode 1. That helps me out massively because I don't have to write out the same code every time. Then we have our actions. So I've added an action called break till dirt. So can you guess what that does? Till meaning until, by the way. So next is our starting and ending points. So point 0 is the first point when I press the activation button. So it starts off as 0, then goes 0, 1, 2, 3, 4, 5, and actually runs 60 times per second, like we said last time. And this action only runs once. And because what I've just said kind of contradicts what it does, I wrote myself this note here that says that it runs forever, because obviously we need to consistently check the screen. This is kind of related to what I was saying in the last episode, but the code that I wrote in the first episode still works, but is getting less relevant as tasks evolve. So some things that I've implemented don't really work with the original idea of how this program was supposed to work. For this task, it was quite a simple change, but in the last episode, I did start to run into a lot more problems, so I am going to be rewriting this and kind of getting more specific code for different functions. But that's when I think I'm going to do an improvements video where I go and look at previous tasks and see if I can improve on them. So then I've set the activation button, and I had to write myself a note, which is 80 is numpad 2. This is because I'm not sure if what I'm using to detect my keyboard presses has a human understandable name for the number pad buttons. So, for example, if I used shift, I would just write, instead of this, I would write shift, right? But for the number pad buttons, I couldn't actually find out if it had a human understandable name for them. And so what I found was it also accepts numbers, and that the 2 on my number pad is number 80. So then this brick till dirt, breaks blocks until it sees dirt. Did you get that right? So again, this is going to look complicated for anyone that doesn't know programming or just started to learn, but I kind of wanted to show off some of the main concepts, so hopefully in the future things like this start to make a little bit more sense. So this is the C amount. This is the number of pixels on the screen that have to be mud colored for the program to break the block in front of my character. I set this to 4000. This was just done through testing and getting a value that doesn't have too many false positives, meaning the times when it thinks it sees mud but actually doesn't. So it has to see 4000 mud colored pixels for it to break a block. Then it creates what I've called the mud mask. This is all the areas of the screen that are a specific color, and this is what you see in the black and white display. Then the program counts the number of non-zero numbers inside of mud mask. So mud mask stores a really long list of all the pixels it's asked to look at, so all the pixels in the center of the screen. Then it stores a 1 if the number is mud colored and a 0 if the number isn't mud colored. So this counts the number of 1s and says if it's greater than the amount that we set up here, so it's more than 4000, then press the left mouse button or hold it down. And then this is a bit more advanced. All you need to know is this code will continuously run until the number of 1s is less than 4000, and at that point this code will stop running and the mouse button will be lifted up. So a mouse button is lifted up when something that isn't mud is being displayed on the screen. After all that's happened, it does break till dirt again, so all this code happens again, and that's why this says it runs forever, because when this code has stopped executing, it then says do it again, so it continuously just loops round and round and round. I think with the speed, the only thing that could really help out is a Minecraft mod that has like direct access to the game, so it can stop me when I'm not looking at mud anymore. But with like the dark areas, I think the only thing that could solve that, apart from the Minecraft mod that could just detect if I'm looking at mud definitively because it has access to the game, would be a machine learning model which is trained on identifying mud blocks. That would make the code run a lot slower, I think, especially on my PC, and I think it would be so slow that we would be moving and probably breaking a lot more dirt. But those, they work in quite an interesting way, where they like learn the shapes inside of the image. So like here, it would maybe learn that mud blocks have diagonal lines and just be looking at them, or maybe it like learn that there's these kind of blobs around, and that like massively speeds up image recognition because it's not trying to look at all the pixels at once. It's just looking at like if it has diagonal lines or something like that. So that would probably help it in darker areas where it'll probably still be able to see, like on some of these darker areas, you can still see it has diagonal lines and stuff. Maybe, I don't know if that's getting a little bit too dark. I don't know if you can see that. But in some of the darker areas, you can kind of still see it has lines and stuff like that. So I think that would probably really help it out, but obviously, yeah, it would not run. It would take a long time to train as well. I would have to get so many images of mud blocks and so many images of dirt blocks and different things, and it would have to do a lot of training. I do not have the computing power, and I do not have the time to go and get all those images. Hang on a second. Couldn't I just... Yeah, I should have just done that, shouldn't I? Maybe this was a bit of a overreaction. But you know what's not an overreaction? The fact that if I have to go and place any more mud or collect any more clay from these platforms, then I'm gonna explode with boredom! I just can't do it anymore. So I'm gonna get my computer to do it for me. And computers can't feel emotion yet, so it should be fine. What I'm thinking is that the task seems quite simple. I think it'll just be like collecting the bamboo in the first episode. There might be some inconsistencies with movement, like there was with the bamboo, but I think I've learned enough that this task is gonna be quite easy. Oh, I hope that's not foreshadowing. Oh wait. Do I? I want it to go smoothly is what I'm trying to say. So currently in the test world, which is why I'm in creative mode and why I have resistance. Just so I don't die to anything. What I'm thinking is there are kind of two ways I come up with doing this. So the first way I was thinking is just starting looking at this block and then just having it go like this and place a row, then move back, place a second row and do that right down here until we get down here, and then it'll go down here like this, and then that doesn't work. Right. So then I was thinking, well, maybe I can get to the end, turn, and then go back down like this, and then it gets to this point, and then it could kind of move out, turn, place. I don't like the amount of turns it has. That's my problem with this method, because I feel like there's just too much opportunity for it to go wrong. Like we've seen previously where it's a little bit just inconsistent with a lot of movement, where I feel like we're just going to fall off the edge a lot. So my second idea was to start off looking this way, and to start by looking down and making sure we're straight with the blocks. So we move this way. That's what I have to do with both methods. And then we jump place, and then place the first line like this, or maybe holding down shift just so we don't accidentally fall off. And then we get to this point, and then all it does is it looks up like that, and then just places the blocks like this. And then once it's done with that, it moves forward and places the blocks. And then we're going to get to the end, and we'll be like this. So it's potentially just a little bit easier to program, so hopefully that'll make it easier to also test, but also I think it's going to be a little bit more consistent. I'm hoping. We might get into a situation where it goes to move forward and then moves forward too much and falls down, potentially, or doesn't go forward enough. That's the only problem I can see. Potentially, oh, this is an interesting idea. Potentially it could... Wait. So we've got the first line, then we move... We go ba-ba-da-ba-da, and then we go ba-ba-da-ba-da, and then we need to move forward. Maybe it could move forward until it can't see mud anymore. Because we actually have that script from over there in which detects mud. Because these two colours are very different. Potentially clay, if it turns into clay, we could run into a problem. You probably have to just test for clay. Like, clay is very different to either of these colours. So... if we just test for these two blocks, if these two colours show up, if these two colours aren't there, then we know we're looking at this. Or maybe we just test for brown. Oh, I'm an idiot. Yes, we just test... we just test if there's brown in the middle of my screen, then we know to stop moving forward and to start placing the next line. There is also a problem, I'm not sure how much of a problem this is going to be, but there's a problem of, if we're going down and run out, then I need to middle click, because middle click will... either move to, if we've got more in our inventory, it'll move to that, or it will grab it out of our inventory and put it into our hand. So I also need something that goes and places it down, but every time it places one, it clicks just to make sure it's still got some there. Maybe we could detect like the item in our hand. Oh no, maybe because like if we do like this, we might get confused with like that. I don't know. I'm thinking detecting the item might be a bit difficult because it might see the block underneath. If we're just doing colors, it might just see this block underneath if I'm like this. So it might kind of go, that's fine, even though it's like that. Maybe we could detect if there isn't my hand there. Maybe there's a color we can get with my hand that we can go and so if it kind of runs out, it sees my hand. Yes, I'm doing it the wrong way around again. Yeah, I need to detect if my hand's there, not if the block isn't there. Then maybe you could then middle click or look at it middle click and then go again. And then maybe if that doesn't do anything, it stops. It'll need something like that. So I think we've got a pretty good idea of how this is going to work. I think what I'm going to do is I'm just going to go and work on getting the code. I think it's going to be pretty simple. Like this first line, jump, place, and then placing it all in a line. I think that's going to be pretty simple. I'm going to go and work on that. We'll get to this point, and then let's go and start figuring out how it's going to specifically do everything else. Okay, so that was pretty simple. I think what I'm also going to do, I got this suggestion in a comment last time, so thanks for that. They said, why don't you push up against a wall, or like in a corner, I think there was a suggestion. And you know that you're in level, that you have to move the same amount this way each time. So all I have to do is, can I get myself lined up? And then, that should be good enough. And then if I press the 3 button on my number pad, all it does is it jumps, places a block, presses shift, then presses A, and then holds down the button and just places a line like that. And there we go, it's ended. Right, so now I've got two options. So I can either move the mouse so it looks up until it sees spruce wood, or I could move forward in tiny amounts until the center of the screen sees oak wood. I could potentially hold shift and move forward. Ooh, that one might work because it doesn't... Oh, no, wait. Am I getting too close to the edge? Oh, yeah, maybe. I don't know. I don't want to accidentally step off the edge. Oh, like that. How do I even do that? How do I even step off the edge there? No, okay, let's look up. Let's look up. So it's going to look up until it sees spruce, and then it's going to just move across like this. Then it's going to walk forward until it sees spruce, and then place. Shouldn't be too difficult with what we've already implemented. Let's go and have a look. So I've written all the code, and I'll go and show it off now. So if I just go and line myself up like this, and like that, and press 3. First off, it does what we saw last time, just goes and places the blocks down this row. Ooh, is it going to do it? There we go. So what it does is it looks up until it can't see mud anymore, and then moves down the line, placing mud. There we go. Beautiful. Now you might have noticed a speed difference in placing the first row to placing the second row. I have been tweaking settings for a long time now, and this is the speed where it makes the least amount of errors. Now what it's doing is it's moving either left or right until it can't see mud or clay anymore, and then placing down some mud. I have had it moving faster at a more reasonable pace, but it just tends to skip blocks then. I think just because it can't see the screen fast enough. So this is one of those tests where I think I was saying last episode where I think it would work better if it can kind of make its own decisions, and that's what I was kind of trying to do in this case. And I think for elytra flying, that definitely should happen. And I think that like with long journeys, there's a lot of time with elytra flying when you're just gliding through the air that you can kind of make decisions, and so things can be a little bit slower and it's not really going to impact the program very much. But I think in these situations, this is such a simple task, and such a simple task that I could get done using other methods a lot faster. Like what it does at the start is so much faster. Even though it's holding down shift the entire time, it's so much faster than doing this. Now it does have some error correction, which makes it potentially slightly better than doing a method that just follows a set way each time, meaning that if it spends too long moving to the right and doesn't see an empty space, it will move forward a little bit and see if it can see an empty space, and then if it does, place a block. There we go, just did it then. And then it'll move back into its previous space. Now moving back, I have found, because like I said last time, there's inconsistencies with movement. Ooh, there we go, is it? It got stuck. Is that better? There we go. So I had to move it there. It got stuck on the wall. There's little inconsistencies with movement, which mean that it can move back further than it moved forward and then mess up, but I have tried to add like little things like that into it. I think if I continue to add stuff to it, potentially we could get it to a point in which it's fully autonomous, but I don't know how fast it's gonna go. Because like this is the speed of making minimal mistakes. Oh, is it? Oh no, it is failed. It's messed it up. It's messed it up. Right, I'm going to end it there. Now, what it does to determine if it's at the end of the row is it just places down 15 blocks, because it's a 15-15 square. So it does 15 rows of each 15 blocks. I think in reality, what it does the first time, just shifting and then moving across, if it just did that and then moved forward a bit and then did that again, I think we might get a better system. Potentially we might have to add some things in where it moves forward until, let me stop it. So then it like moves forward until it sees a space and then places and then just goes across a set for a set amount of time. I'm thinking that might just be a lot better. I think I've overcomplicated this. But unfortunately, that's all the time we've got for this episode. So I'm going to have to actually split this episode up into 2 parts. And if you come back next week, you'll have your part 2 and your answer to how I solve this problem. But anyway, I hope you enjoyed. If you have any suggestions of things that I could do in this series, put them down in the comments. If you have any improvements on things that I've done, put them down in the comments. And if you try out this yourself and you make anything cool, put it down in the comments. Or even if you don't make anything cool, just put it down in the comments. But anyway, I hope you enjoyed, and goodbye.